All right, we have a trig equation here that looks pretty weird because of all the stuff that's going on in there, but let me tell you what I look for when I solve these. All right, I see a trig function squared and I see a trig function not squared. And so in that case, what I'm going to do is move everything over to this side. Secant squared x minus 2 tangent x minus 4 equals 0. Now, I did that because it looks quadratic in form. Something squared minus something not squared equals a constant. Quadratic. Now, the only problem now is that these trig functions are different. We can't solve it unless they're the same, because there's not anything we can factor out to force the terms to be the same. So I'm going to use a Pythagorean identity. 1 plus tangent squared x equals secant squared x. And I'm going to substitute that in there. So for secant squared x, I'm going to write 1 plus tangent squared x. And then I'll continue with the rest of the equation. Minus 2 tangent x minus 4 equals 0. Next, I'm going to combine like terms. So the only terms that are quote-unquote like are 1 and negative 4. So I will have tangent squared x minus 2 tangent x, and I'm going to add 1 and negative 4, which gives me negative 3. Now here, because I have a quadratic and I don't want to go crazy, I'm going to let u equal tangent x. And then it will look really nice. U squared minus 2u minus 3 equals 0. So factoring this, or trying to factor it, let's see what happens. This is my only option. So I know that the signs have to be opposite, and the sum of 3 and 1 with the proper signs has to add up to negative 2. So that means I'm going to have negative 3 and a positive 1. Now, that means that u minus 3 equals 0, and u plus 1 equals 0. So that tells me that u equals 3, u equals minus 1. So tangent of x equals 3, and tangent of x equals minus 1. Now, tangent of x equaling 3, that's not standard. That's not standard. So we're just going to use arctan here. X equals arctan, or tangent inverse of 3. And over here, I know that if I look at my circle, that the slope of minus 1 is right down here. And that's where sine and cosine are equal. Square root of 2 over 2, square root of 2 over 2, equal but opposite in sign. So that's going to be a denominator of 4. So that's 1 pi over 4, 2 pi over 4, 3 pi over 4. And then 4, 5, 6, 7 pi over 4. Now over here, I'm going to type in the arctan of 3 into my calculator. Let me get my calculator here. So tangent inverse of 3. I made a typo there. Gives me 1.2490. So x equals 1.2490. Now that's not the only one over the interval from 0 to 2 pi, which is what we're working on here. I know the original equation didn't say it, but that's what we're working on. So if I think about my unit circle, I know that when the arctan of 3, 1.2490, is going to be in quadrant 1. 1.2490. And the other quadrant where tangent is positive is in quadrant 3. So 1.2490 as a reference angle. So that means my other angle here is going to be pi plus 1.2490. And so then I have 4 angles, 1, 2, 3, 4, that solve my equation on the interval from 0 to 2 pi.